In this video, we are going to learn how to use sum to product formulas to solve trigonometric equations. So we're going to solve each equation on an interval from 0 to 2 pi, not including 2 pi. So we'll start here with sine of 2 theta plus sine of 4 theta, which can't necessarily factor because the angles on the inside are two different angles. So they don't have that common inside angle. But I do know a sum to product formula I can use for sine of an angle plus the sine of an angle. And what's nice with this becoming a product is that it's equal to 0. So if you have a product of two functions, you can set each function equal to 0 because of the zero product property. So let me quickly go over the sum to product formula for sine, which is sine of alpha plus sine of beta is equal to 2 sine of alpha plus beta over 2 times cosine of alpha minus beta over 2. So knowing this, I can rewrite this equation as 2 times sine of 2 theta plus 4 theta, which is 6 theta, divided by 2, so that's 3 theta, times cosine of 2 theta minus 4 theta, which is negative 2 theta, divided by 2, which is negative theta. Now, I know that cosine's an even function, so I can just eliminate that negative on the inside. Give me 2 sine of theta times 2 sine of 3 theta times cosine of just theta. I can divide by 2 just to get sine of 3 theta times cosine of theta is equal to 0. And I can set each of these factors equal to 0 with the zero product property. So I'll get sine of 3 theta is equal to 0, and cosine of theta is equal to 0. Now, what angles make sine equal to 0? Those happen at the quadrantal angles 0 and pi, as well as 2 pi, but we don't include that one. So I'll write 3 theta, the inside angle, could be equal to 0, plus the period times the integer constant. That's one general formula for all of these solutions. And then also at pi for sine, so it'll be 3 theta is equal to pi plus 2 pi k. And to finish out those general formulas, I can divide each of them by 3 just to get what theta is equal to, since that's what I'm solving for. So I get 0 plus 2 pi over 3k, and then theta is equal to pi over 3 plus 2 pi over 3k. So these are two of the general formulas. Now for cosine is equal to 0 at the quadrantal angles pi over 2 and 3 pi over 2. And since cosine is also a periodic function, we can put plus 2 pi k to list out all solutions, but we're just going to list out the ones that land on our interval now by going through our general formulas. And I'll start with the 2 for sine. So for sine, I don't want to use a negative k value because I'll go backwards from 0, which I need it to be greater than or equal to 0. So I'll start with using 0 for k, which does give me that solution of 0, which is on my interval. And then I can plug in 0 for k for the other formula. It gives me pi over 3. Now I can plug in 1 for k, so 0 plus 2 pi is 2 pi over 3 is 2 pi over 3. And I can plug in 1 for k, and I get pi over 3 plus 2 pi over 3, which is 3 pi over 3, which just simplifies to pi. Now I can plug in 2 for k, it gives me 4 pi over 3 plus 0, so 4 pi over 3. And that gives me 4 pi over 3 plus pi over 3, which is 5 pi over 3. And then I could try plugging in 3 for k, which gives me 6 pi over 3, which is also known as 2 pi. But at that point, 0 plus 2 pi would equal 2 pi, and that's not on my interval. So I'm going to leave that one out. Now let's use my cosine function. I don't use a negative k, because again, I don't want to subtract 2 pi. That would make it negative, and that wouldn't be on my interval. So I'll get pi over 2, and I'll plug in 0 for k, and 3 pi over 2. And then if I were to add 2 pi to pi over 2, 5 pi over 2 is not on this interval. So I would have to stop there. So I get 1, 2, 3, 4, 5, 6, 7, 8 solutions to that equation. Now let's look at the next example. Here I have a difference of two sine functions. And again, they don't have a common inner angle, so I can't factor yet, but I can make this a product with that sum to product formula for cosine, which I'll rewrite down. So cosine of alpha minus cosine of beta, since I'm subtracting two cosine functions. And this is equal to -2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. So following that formula, this equation can be rewritten as -2 sine of 4 theta plus 6 theta, which is 10 theta, divided by 2, give me 5 theta, times sine of 4 theta minus 6 theta, which is -2 theta, divided by 2, this gives me negative theta. And since sine is an odd function, I could factor out a negative, making this a positive 2 on the outside. So 2 sine of 5 theta times the sine of theta. And I can also divide by 2, give me sine of 5 theta times sine of theta is equal to 0. And I can set each factor equal to 0 with a 0 product property. So I'll have sine of 5 theta is equal to 0, and sine of theta is equal to 0. Now, first I'll solve the trig function on the left. So where does sine equal 0? And I'll set 5 theta equal to that. Well, that happens at the quadrantal angles 0 and pi. So I'll have 5 theta is equal to 0 and pi. But since I have a period change, I should treat these like general formulas to start. So it'll be plus 2 pi k for the period of sine being 2 pi. I can now divide by 5. My general formulas for the solutions to sine of 5 theta equals 0 will now be 0 plus 2 pi over 5k, and theta is equal to pi over 5 plus 2 pi over 5k. And now I'll find the general formulas for sine of theta is equal to 0, which also happens to the same quadrantal angles, 0 and pi, and the period of sine is 2 pi, so I'll do plus 2 pi k. So now using these general formulas, I'll list out all of the possible solutions, starting with my equation on the left. I don't want to use a negative k, because that'll bring me into the negative values. And I'm not going to find any solutions there, so I'll just start with k is equal to 0. So it'll be 0 plus 0, which is one solution. Then pi over 5 plus 0, which is pi over 5. And then plug in 1 for k gives me 2 pi over 5. And then 2 pi over 5 plus pi over 5 is 3 pi over 5. Then plug in 2 for k gives me 4 pi over 5 plus 0, which is 4 pi over 5. And 4 pi over 5 plus pi over 5 is 5 pi over 5, which is just pi. If I were to plug in 3 for k, it gives me 6 pi over 5. And hopefully you're starting to see a little pattern here as I'm going through my solutions. It's just going up by a pi over 5 every time. So again, 6 pi over 5 plus pi over 5 is 7 pi over 5. And these are still all within my interval, so I'm going to keep listing them. Then I'll get 8 pi over 5 for k equals 4, and 9 pi over 5. But if I were to use k is equal to 5, that would give me 2 pi plus 0, which is outside of my range, so it actually stops here. Now, checking my solutions for sine of theta is equal to 0. I'll get 0, which is already one solution, pi, which is already a solution, and then possibly 2 pi, but again, I don't include 2 pi. So these solutions from these functions already were listed in the solutions for this function. So I get 10 solutions from all of the pi over 5s from 0 to 9 pi over 5. And that is how you use sum to product formulas to solve trigonometric equations.